friends, welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series for the month of January, we are on day 25 where we are going to solve today's statement. The title says minimum difference between highest and lowest of k scores. Okay, so you are given a zero indexed integer array nums where nums of I represents the score of I student. You are also given an integer k. Pick the scores of any k students from the array so that difference between highest and the lowest of k scores is minimized. So given an array of integers, we can pick any scores of k students. So order doesn't matter. Okay, and we have to ensure the difference between highest and lowest of k scores is minimized. Okay, cool. So the problem statement states we have given an integer array and a value of k. We have to come up with the minimum value of the maximum difference between lowest and highest of elements grouped with k grouped with k. So we can form order of any two elements, any k elements, and let's say if we form order of these two and these two, right? So difference between these two is 5. Difference between these two is 6. So we have to difference between mean and max. So mean and max is this here it is 5 and here it is 6. So the output expected is basically 5. But there is other possibility of forming a pair in a such a way 7 and 9 can form one pair where the difference between mean max comes as 2 and difference between 4 1 comes as 3. So that's how we can basically here it is 9417. The difference between highest and lowest is 9172. Okay, so I hope the problem statement is easy and straightforward. So whenever such problem statement is given where we have order is not important, right? And where did you come to know about this? Pick scores of any K students. Okay, so this was my hint to basically identify that order is not important. And whenever one simple hint that I feel one should always apply and think is when order is not important, first stop, sort the elements, and then think because once we sort, things definitely change and become very easy and clear. Okay, cool. Now let us okay, so one thing is clear that we need to sort. So let us check the constraints as well. So if you see the constraint states k is less than length, which should be expected, less than equals to, and it's less than equals to 10 power 3, which is very less. Moreover, the range of each element can go up to 10 power 5. Okay, cool. So my any solution of n square, n log n, or n order of n, everything works because the constraints are small. But we'll try to come up with a solution which would fit into order of n log n. Okay, why n log n? Because I want to sort it. Whenever sorting comes, n log n is the minimum and constraint, right? Cool. Now, once we sort the array, simple formula is we can keep a running count, we can keep a running minimum value forming pairs of k groups, right? So, let's say, so this was the input. We sort the input first, 1, 4, 7, 9. Cool. So this is how the input transforms. So once this is how the input becomes, we can keep a running minimum value of k group. So the first k groups consist since k is 2, the first k group consists of 4 minus 1 is 3. Now the running count is 4 comma 7 where again difference is 3 minimum and maximum, and here the difference was 2. So my 2 will get updated here because I got the minimum value here. So that's how I can return the answer. Okay. I hope the solution approach was very intuitive and easy to understand. Let's quickly implement the solution as well. We want minimum. Let me declare a int answer with the highest value possible at the first. Okay. Now I want to start iterating on I equals to nums dot size. Okay, I want to start from, I'm forming k ranges, right? So let me start from k minus 1th. So the first range, the first group, k group where it is ending. And I is less than n, I is less than nums dot size I plus plus. Okay, great. Now I'm starting here. Now I want to check if I can update the answer. So answer will update like minimum of answer comma nums of I. Why nums of I? Because if my range is ending at, let's say, this position, so after sorting, after sorting, if my range is of these two elements, after sorting, the last element will be the highest, and the first element in the range, in this K group range, will be the minimum, isn't it? So the difference would be, the maximum difference between highest and lowest would be difference between the last and the first, isn't it? So that's what I want to do. So nums of I is the last, and I want to subtract nums of first. How? Nums of first, I minus k minus 1. Simple. Okay. So this will give me the first element in the range, which is ending at I. Okay. Great. Why k minus 1? Because k is 1 based indexed. Cool. Now let us try to run and check our output. It's very simple code, guys. Okay. We have some error. Okay. K is equals to 2. Output is minus 5. Answer is 2. Okay. We are declaring answer as int max. I assigned to k minus 1, I less than nums dot size, I plus plus, answer equals to mu answer comma nums of I minus k minus 1. Okay, let's try to dry run this. K starting from k equals to, let's say for this test case, right? K was starting from 1. Okay, my bad, I forgot the first step, which should be to sort. Okay, the first crucial step was to basically sort all the elements. Then only this logic will work, because my assumption is elements are in increasing order. Okay, let's try to submit and check for the hidden test cases. Meanwhile, if you are guys new to the channel, please consider subscribing to the channel. And if you have any queries or you want me to make videos on some topic or questions, please do let me know in the comments. Okay, cool. And that's how the today's problem statement is successfully accepted. Let's quickly discuss the time and space. I think I already discussed. The time complexity is nothing but O of n log n, because n log n is for sorting and the another extra for loop. Okay. And in terms of space, we are not using any extra space, so it should be O of 1. Okay, cool. Thank you for watching the video.